and we will be putting it on YouTube. Good. And let me share. So excited for so many people to show up today. I'm also really excited about your session. I know I've done my share of vector databases, but not yet in Fabric. So I'm really excited to learn how that can be done. And let me shift here to the slideshow. So welcome to Microsoft Fabric's user group. And I just want to let you know about some of the upcoming events that we also have coming. So next week on the 28th of January, we are having Fabric Adoption Roadmap, Lessons from Napoleon Bonaparte with Joe David. Very excited about that. Always great when you can still learn from someone like Napoleon Bonaparte. On the 8th of February here in Denmark, we have Data Saturday at Microsoft. I'm coming. I know a lot of other people are, and I will be talking about how to make your AI responsible, secure, and compliant, among other things. And then on the 11th of February, we have Intro to PySpark in Microsoft Fabric with Jared Cohen. Also quite an exciting session. And then on the 19th of February, we're doing improving efficiency of data transformation using PySpark transformers and LLMs with Bala Dasujai. So I'm quite excited about that also. Many good sessions coming up. Now, as I said, this session will be recorded. It will also be made available on LinkedIn and on our YouTube channel. We will also be sending out feedback mails. We're setting up the flow currently, and we'd always want to get your feedback and learn how we can get better and create even better sessions in the future. So today, really, really exciting. It's going to be about Fabric databases and AI using vector search in Fabric databases for AI architectures. Dennis Torres, thank you so much for joining us and for giving us this session. I really look forward. I'm going to stop sharing and I'm going to leave it to you. I'm going to have an eye on the questions in the chat. Tell me, do you want me to tell you when there are questions, or do you want to take questions at the end?
You can tell me if the question is related to what I'm talking. You can tell me at the moment.
All right, I will.
Thank you. So I'll be talking about Fabric database and AI, how to use AI with Fabric database, especially related to vector search in Fabric databases. This is an interesting new feature using vector search in relational database, especially Fabric database. So we'll talk about the feature, how the feature works, but we'll also see some point of views about what can we do with this feature, how can we use this feature inside AI architectures. So this is me. I'm a former data platform MVP. I work in Malta. I have a company in Malta that our software, and I provide access to Onyx data in UK. I'm a Microsoft trainer with some Microsoft certifications and leader of the Malta Data Platform user group. On the right side of the screen, you can see my contacts. It will be a pleasure to stay in touch after the session, stay in touch in social medias and so on. Any questions that you may have, you can send to me, no problem. So it will be a pleasure to stay in touch. Let's start talking about Fabric database, because Fabric database itself is already something very new. Out the demonstrations, everything I'll do is focused on Fabric database, but is not on the basics of the Fabric database. So let's review what this is. What are Fabric database? Basically, they are Azure SQL. Fabric database are Azure SQL. So Fabric created like another layer to make it even easier for us to use Azure SQL and to integrate Azure SQL inside Fabric. But what's important in this case is that the features that I will demonstrate in relation to Fabric database, they are the same features that you find in Azure SQL, because Fabric database is Azure SQL. So you can use this demonstration that you make inside Fabric database, or you can use inside Azure SQL itself. So one main point is that these demonstrations work in Azure SQL. About Fabric database itself, I have other videos in my YouTube channel, for example, talking about more basic details about how the Fabric database work. But today I'll focus on vector search and using this vector search in AI chat solutions. Let's first understand a bit about AI architecture and how the vector search fits inside AI architecture. This may be a review for some of you, or it will explain a bit about what vector search is. So, one very common AI architecture is the RAG architecture, retrieval and augmented architecture. Basically, is an architecture that allows us to feed a model, to feed, let's say in a simple way, a chatbot with information from our own company. So we can get documents, any kind of information from our own company and feed this information to a model like to a chatbot and get answers from this information. Then a technical word that we use a lot is embedding. What this means? Embedding is a specific type of vector. What this means? Vector is a mathematical element. Vector is a mathematical element that which can be used for many different purposes. But to make a better indexing in relation to the meaning of documents, meaning of files that we have, we create these vectors over the content of our files. When the vector is created like this, the vector is called as an embedding. So in some contexts, the word embedding and the word vector have the same meaning. They are the same. Although vector has a broader meaning in relation to mathematics. Vector is used for natural language processing and search. We use the vector to, in some ways, index the meaning of a document and search our content according to this meaning. So we can use natural language processing and search with embeddings. So vector and embeddings are synonymous and in the context of AI. So let's talk about RAG on Azure. This AI architecture on Azure. What happens? On Azure, we have the Azure OpenAI services. We have the Azure OpenAI services, which we can use to create a model and make natural questions, like if we're creating our own ChatGPT, for example. What's the process of RAG architecture on Azure? Let's imagine the user makes a question through Azure OpenAI. The user sends a question to Azure OpenAI. Of course, in a production architecture, there may be many layers between the user and the Azure OpenAI itself, but I will not get in this level of details. So the user makes a question. So we have the Azure OpenAI, and the user makes a question. We think this question, many people may think this question goes directly to the model for the model to make an answer. No, not exactly. It's not how it happens. There is an element that doesn't have a precise name. And here in the image, I'm calling a coordination element, which receives the user question. This element first receives the user question. And then AOA, I'm mentioning Azure OpenAI. What Azure OpenAI does? Azure OpenAI creates the embeddings for the question. The question the user is asking is transformed in an embedding, in a vector. So the coordination is responsible for this. Inside Azure OpenAI, we use embedding models to create embeddings. So the question the user made is transformed in a vector using this embedding model. Then Azure OpenAI use these embeddings to search for related documents. So it's not a text search. We are way beyond here in relation to a text search. The embeddings analyze the meaning of a document, what the document refers to, what the document is talking about, and hash this meaning in a vector. And the question is transformed in an embedding, and the search will happen with this embedding. So we'll go to the what in the RAG architecture is called the retrieval stage. So the coordination will get the embedding of the question and search for content using the embedding of this question. It's expected that at this point on the retrieval stage that all the documents that we have already have their own embeddings created. The documents are stored somewhere and have their embeddings created. So we are searching, comparing the embedding of the question from the user to the embedding of the documents. And what are we looking for? We're talking about vectors, numeric vectors. Yes, we are looking for the closest distance between the question and the document. The documents closest to the question, which have the vector closest to the question in a mathematical way, are the documents that are more probable to answer the question. So, using the documents which were located from the search stage, the Azure OpenAI will build a prompt to the model using the located documents. So the documents which are located are organized building a prompt, a message prompt. So many people think, oh, I'm sending a simple question as a prompt to OpenAI, and OpenAI is finding the answer in my document. Not exactly. How this process that I'm explaining is happening. I send the question is transformed in an embedding. The embedding is located among our data becomes part of the prompt, but not all our data, only the located data, only the documents which are closest to our question becomes part of the prompt. And then the prompt is delivered to the GPT model. Here comes the GPT model receiving a prompt with the user question and the documents, the information of the documents that are more probable to answer the question from the user. And the Azure OpenAI receives the answer from the GPT model and delivers the answer to the user. How does it work? Here, the coordination builds the prompt, sends the prompt to the GPT model, the GPT model processes it, sends the answer, and the answer is delivered to the user. The main model is considered the GPT model. And many people think only about the GPT model. But in a RAG architecture, inside Azure OpenAI, all these steps are happening. The transformation of the question in embeddings, the search for the content using a vector search, and then the answer of the question. Some limitations related to the RAG architecture, or specifically to this format of the RAG architecture that I explained. It's a document search. It's searching for documents which are close to the question made by the user. It's not a database search, it's a document search. And the result of the search is limited by the size of the prompt that the GPT model can deal with. So the GPT model can't get out the documents and process out the documents. So a way we have to limit this is exactly to make the vector search. Making the vector search, we get the most probable documents to contain the answer for the user, and we deliver these documents to the GPT model inside the prompt, and the GPT model makes the answer. It lacks database level precision. It lacks database level precision. Let's understand exactly what do I mean in relation to this lack of database level precision. Could you list the orders from customer XPTO? This is the kind of a database query. If this question is transformed in embedding and then searched among documents which are provided by the company, we may have a limit of the documents that will be retrieved. The size of the prompt will limit the documents that are retrieved. Can we ensure that we will retrieve all the orders of this customer XPTO? No, we can't be sure. We can't be sure. So in these some situations, we may have a lack of database level precision on the answer of the question. Could you list the sales from John? The same will happen. The question is transformed in an embedding, and the embedding is used to locate the documents which may have the answer to this question. Uh, if a single document without the sales from John is found, great, that document will generate the answer. But if the documents are, for example, a list of invoices, one invoice in each different document, there will be a limit of the number of the documents which can be provided to the GPT model. So we can't be sure that we have database level precision answer. Could you list the bicycle orders? The same. So in this way that I explained it until now, you may reach a point that you don't achieve a database level precision. It doesn't mean that this is a totally bad thing. It means that it has a different purpose. It has a different purpose. It's looking for answers in documents. It's looking for knowledge in documents, not database information. To look for database information, the architecture may be slightly different. This is a point that I'm highlighting, but uh, let's see how this point is affected by the new features. What we have today is vector search inside a relational database. We can make vector search over records in a relational database. So, vector search in a relational database has some possibilities that we have in relation to this, some possibilities that you can achieve in relation to this. It can be used as part of the RAG architecture. We can use the vector search in a database as part of the RAG architecture instead of using, for example, the Azure AI search, which is one of the most common document repositories using the Azure AI search. Instead of using Azure AI search, we can use a vector search in a relational database. So it's a different method to implement RAG. I explained the entire process of RAG inside Azure OpenAI. We can get a piece of the vector search in Azure OpenAI and replace it by something built by us, something built by us inside a relational database. And in some situations, in some scenarios, this may achieve a better result than what we would have using only the vector search of OpenAI. Uh, it can be a workaround for database precision answers. It can provide more precision, database precision level answer in this case. We can use this feature to build an architecture that will get closer to database precision level answers. We could consider this as well as an advanced text search. It's way beyond the previous text search methods, such as full text search from SQL Server, for example. Making a vector search, make a search in text using a vector search in a relational database is way more advanced than the old text search methods. Uh, natural language search, yes. This means that we make a question and we find the record related to that question in a natural language method. And this doesn't require to be part of a RAG architecture. The vector search itself can be used by itself as a complete solution if this achieves our purpose, and we don't need to fit this feature inside a RAG architecture, a complete AI solution. We can make one step further and fit as a piece of an AI solution, but is not required. This feature by itself, the vector search, is extremely powerful. Let's talk about how this feature works. How the vector search, how this feature works. The demonstrations that I make, I focus on a table which I have from Walmart products. I have a table with Walmart products and I will search products in this table. So the main new features that we have that we are relating to vector search are that we have a vector data type. So we have a specific data type that we specify in fields in a table, and we say this data type will contain a vector. That's it. This is one of the main features. And the second main feature is the vector distance function. The vector distance function in SQL can get two vectors and calculate the distance from them. And the distance between the two vectors point to us how related the two informations are. When I'm saying two vectors, I'm saying each vector is an embedding created from one specific content. Calculating the distance and making search in a database based on the distance of the vectors allow us to find the information which most relates to a specific content that we have or which least relates to a specific content that we have. So we can identify the vector distance. And this is just the beginning. There are other functions related to vectors that make it even more powerful. But it goes beyond the session today. But to make a complete work using these features, to make the work complete, we need to take some additional steps. Let's consider that I have that table with products from Walmart. I have a table with products from Walmart. And then I add a vector field inside this table. Okay, I included a vector field. The field is completely new. What the first thing we need to do? Well, the existing content needs to have the embeddings created for it. Each product, each record needs the embedding to be created for it. So the first step is generating the embeddings for the records that we already have in the database. And when I say generate the embeddings for the record, what makes sense in this case? I'm talking about a table with products from Walmart. In a table with products from Walmart, I have the product name. I have the description of the product, what that product is. And I have the category of the product. All these three, for example, are text fields. Text fields. If I would search the products by a text inside the description or a text inside the product name, the search would not be so precise. So I can use the vector search to solve this problem and allow a natural language search inside a products table. In this example, I start generating the embeddings for the records. Before mentioning the second step, how can I generate embeddings for the records? Is this a new feature in Azure SQL? Is this a new feature in Fabric database? No, it's not. If I want to generate the embeddings for the record, I need to have Azure OpenAI and I need to have a model inside Azure OpenAI to generate the embeddings. I need to have a model inside Azure OpenAI to make the generation of the embeddings. Okay, so I need to have a model to generate the embeddings, but how I call this model from a database, from a relational database, a Fabric database? Simple. Very recently, you may have heard about a new store procedure that allows us to make an API call. From inside the SQL, we can make an API call, and our API call can be used to call the embedding model in Azure OpenAI and make the generation of the embedding. So the features itself alone will not work if we are not capable to make external calls, call models to make the generation of embeddings in this example. So generate embeddings for the records is the first step. Then, after I have the table and each one of my products has their own embedding, the user will make a question. Let's consider our user will come with a question. What I need to do with that question, to search that question, I need to generate the embedding for that question, for that natural language question. I need embedding as well. Then, if needed, I can build a prompt for a question to go to AI. Um, Sorry, I missed to be explicit about the middle point here. Once I have the embedding from the question and my records have the embedding in the table, that's the moment where I can make a search. I can make a search by vector distance and locate the products which are related to the question of the user. Simple like that. After the second step, I can already make a search and get the result. If this is enough for my solution, okay, this is enough for my solution. I made a natural language question inside the database and got my answer. That's okay. But maybe I would like OpenAI, a GPT model, to make an analysis of that answer. So instead of stopping at this point, I can get the products that I found and build these products in a prompt that I will send to a GPT model. I will again make an external call, this time sending the question to a GPT model. Do you notice how I'm making in-SQL steps that in a previous explanation I said these steps would be internal in Azure OpenAI? Yes, these steps could be internal in Azure OpenAI in some scenarios of this architecture, but in this scenario, I'm making these steps like building the prompt inside SQL and sending the prompt ready to be processed to the GPT model. And then I execute this question. If I build the prompt, I want to execute the question, execute a natural language question to the GPT model. So these are additional steps that we will need to have, we need to build over them to give purpose to these new features related to vectors inside a relational database. And there is a procedure that makes external calls, external API calls, is the SP invoke external REST endpoint. So from TCQ, we can make external API calls. Any API. This is not specific to AI or to OpenAI, but this is essential for the work of AI and OpenAI. It requires a credential object. Of course, we will not leave our Azure OpenAI completely open for anyone to access. We need to put a credential. So we need to create a credential object inside Azure SQL, and this procedure will use this credential object. Can call Azure OpenAI services, can call for embeddings to create embeddings, or to make questions to a GPT model inside Azure OpenAI services. But only call Azure URLs. This procedure can only call URLs inside Azure, not outside Azure, unless we make a specific workaround to allow this procedure to call URLs outside Azure. How? Using an API management. Using an API management service in Azure, I can map an external API to inside Azure. And in this way, I can call an external API from inside the SQL using this stop procedure. But I'm only mentioning that this is possible. This is way beyond our subject today. Okay, so first, creating the vector field. So I have a table of Walmart products, Walmart product details. I need to create a vector field. So I define outer table, add the name of the field and the type vector. The type vector, size 1536. Why the size 1536? Because the size depends on the embedding algorithm that we'll use to create the vectors that we will insert inside this field. Each algorithm generates vectors of different sizes. Depending of the algorithm that I decide to use, I will need to define this field with some specific size. The maximum size that this field accepts today is 1998. This is the maximum size of the vector data type inside Fabric database. Then, some examples of algorithm size. Text embedding AADA 002 is the one that I'll be using today is 1536. You can notice by the size. There is a version suite of this Green Test Embedding Suite Large. This is 3072. I put this in red because this means that we can't put the result of this algorithm inside this data type. Not yet. So we expect in the future the limitation of the size of the vector may get better. We may have bigger vector sizes, so we can use better algorithms like the test embedding suite large. I'm still studying, analyzing if it would be possible to break a vector into fields. I'm not sure if it would be possible to do something like that. I'm still thinking about and analyzing. There are other algorithms that produce smaller vectors, like BERT, MiniLM, but these are not even available in Azure, not out of the box, at least. Then the credential. We need to create the credential to access the OpenAI service. How do we create the credential? In my example, the name of the credential is the URL of the Azure OpenAI service. This AI Open Training is my object inside Azure. The rest is the full from Azure, but this starting of the URL is the name of my object. Check the identity that we use here. This is very specific to this stop procedure to invoke external API. We can pass the credential as an HTTP endpoint header. So the credential will be passed as a header for the API. And the secret builds this header by specifying the API key, and I need to put the API key here. I need to get the API key from Azure and put in the database scoped credential. Then, get embedding stop procedure. We mentioned many points in which I would like to generate embedding. So the best way is to create a stop procedure to generate embeddings. So I'm creating a procedure called dbo get embedding. I'm showing a lot of code. Yes, I'm showing a lot of code. At the end, I'll give a reference of a GitHub repo where I'm making all this code available. You can reproduce this example. So I'm creating the procedure get embedding. This procedure receives a deployment name, a deployed model name. This is the name of the model that we use inside Azure to create embeddings. The text is the question of the user, and the embedding itself is an output, is the result that you generate. Okay, then what we have here? We have the SP invoke external REST endpoint, the procedure which is calling the external API. So I'm passing the URL to this procedure and I'm building the URL. You see, I'm building the URL according the URL to call an embedding model in Azure OpenAI using the deployed model name, which the procedure receives as parameter. Then I send the payload. What's the payload? The payload is the question the user made. I need to transform the question the user made into an embedding. So I get the parameter, I receive it with the question, the input text. I use the function JSON object to transform this into a JSON object and send this as a payload to the API that you create embedding. Then this is the parameter with the question the user sent, and then I'll get the result. It requires some knowledge of the JSON format that the model will return, but we can make some tests and analyze the JSON format that we'll receive in return, and then structure the code. This code is already built and it already works in this way. It's extracting the embedding from the JSON result and converting the embedding to vector and returning in the output variable as a vector. So it's a procedure that I give a message to the procedure, a text message to the procedure, and the procedure generates an embedding for this text message. These have multiple purposes in the scenario that I illustrated. For example, first, before really receiving natural language questions from the users, I would like to generate the embeddings for all the records. I mentioned this. I would need to add a vector field to my table, my Walmart products table, and generate the embeddings for all my records. In my example, I have 30,000 records here. So I have a loop of 30,000 records. I'm getting the text field from these records. I'm getting the product name and description from the DBO Walmart product details, one by one, record by record. Yes, I need to make an external call for each record. Then I call the DBO get embeddings, passing the model, passing the text that I generated and getting the output. And then I'll make an update on my products table. I make an update on my products table, inserting the result inside the vector field and proceed. Then I proceed. Okay, so in this example, I'm generating the embeddings for all my records in the products table. Then finally, my result. The actual result from this is that I can make a natural language search. For example, help me plan a high school graduation party. Okay, then I need to generate the embeddings here. The same procedure I need to use again. Now I'm using the procedure to generate the embedding for the question, the user question. I generate the embedding for the user question, and then with the result on the variable search vector, I make a select in the table of products, calculating the vector distance between the question the user made and the vector that I have stored for all my products. Then I'll get all the records which are closest to this question, to the question the user made. All the records is a mathematical calculation. So I'm ordering by the distance, which is the vector distance generated. I'm ordering in ascending order, so from the smaller distance to the higher distance. Okay. The closest to the question to the more distant to the question. And how many of the products closest to the question I want to get. This is specified on the top 10. I'll get the top 10 closest products to the question. Okay? This by itself can be a complete solution. I may not need more AI steps from this, and I mentioned this when I was giving some ideas about what to do with this feature. So I'm using the get embeddings, I'm checking the vector distance. Let's see this working. Let's see an example of this. So I have here a Fabric database. My Fabric database is called Vector Sample. I imported Walmart product details. The links that I'll provide at the end have the data that you can import later to reproduce this example. And let's take a look on the demo one that I prepared. So first screen, I'm just getting 10 records from the Walmart product details for you to see how the table is. There it is. I have product name, description. The description is large, and this data set that I got, all the descriptions start the same and have more content. Categories of the products and the vector. Take a look about how the vector is. It's really a numeric mathematical vector created by the embedding model to express the meanings of this record in relation to the product name and the description. These were the two fields that I sent to the model when I was creating the vector, creating the embedding. Then, let's check how to make the question. Is exactly what you saw in the PowerPoint. I'm making the question, help me plan a high school graduation party. I'll call the procedure to get an embedding for this question, and then once I have the embedding for this question on the search vector variable, I will make a select using the vector distance. You may notice that I'm using the cosine method. Yes, there are three methods of calculating the vector distance, three mathematical methods. Two of them are better used for text. One of them is better used for image. The two which are better used for text, they have different user scenarios. I would recommend start with cosine and then analyze more advanced scenarios later. So there are different mathematical methods to calculate this distance. So let's execute this query and check the result. There is an external call being made to generate the embedding for the question, and then when the embedding returns, it searches the table, checking the vector distance. It even told me which is the distance, what's the value of the distance. And we can take a look on the kind of products that were selected related to party, high school party. That's what I asked, products related to parties. So I made a natural question, a natural language question, and I'm locating products related to that question that I made by using the vector search. Let's see another example. Let's make a different question. My question now is, I would like to cook a chicken teriyaki. So I would like to find the products which are closest to this sentence. So let's run. And again, an external call was made to create the embeddings for this natural language question. And then I have the product name here, the products recommended as an answer to this, and mind that all the products recommended are related to food, and many of them related are sauces related to chicken or to chicken teriyaki, and so on. So products related to what I'm looking for. And these would not have the same level of result, the same quality of result, if I were using a simple text search. I will not get the same quality of result with a simple text search. Okay, let's get back to the PowerPoint. So we saw how a vector search works inside SQL. What's the next step? The next step, which I mentioned is an optional step, is that I can get this result from my search. I can get my search result and make a GPT question with my search result. How I need to do that? It can be done in SQL or it could be done outside SQL. I could have I could have an application that would get this result and then send to GPT. It would be a problem of the application. In our scenario, let's see how we could do in SQL. So I need to use the previous result as a data source and make additional analysis of the product list. What GPT will do is to make additional analysis of the product list and check which products fits better with my question. And I can get explanations about how these products fit with what I asked about. So I need to convert the result of the product list to JSON. So it's the same code that I used to make a question, but now in the select, I need to get the select and convert this to JSON to be prompted to a GPT model. So I use the function JSON object to create a JSON object with the result, with the ID of the product name and description. And then I can transform the records in an array using JSON array aggregation. And this generates my result to build a prompt. Then I need to build a prompt. I'm using JSON functions here as well. JSON object function, JSON array function, JSON object function, but the result mostly is text. I'm building a prompt. I summarized this. I didn't put here the entire system message, which I used, but I'm giving instructions to the GPT model about what kind of analysis the GPT model should do in relation to this. I put together the instructions, the products which I located, which are related to the question of the user. And then I send to the GPT model the question the user made. I send the question the user made to the GPT model. Okay, so build the prompt using the steps I use to build the prompt with the JSON object method with a row system and a row user. This is specific to OpenAI, specific to GPT model. Okay, and then I make the GPT call. I make the GPT call using the invoke external REST endpoint. Invoke external REST endpoint, defining the address for the call, this time calling a chat model, specifying the credential, the same credential I used before I can use now, is the same Azure OpenAI object. Sending the payload, the prompt that I built, I send the prompt that I built and get a response. From the response, this response is more complex. We need to analyze in detail this response, but in this example, I already have here built the query that will extract the actual result from the response. The response is a JSON object, a long JSON object, and I'm extracting the actual result from this response. And final touch, transform this into a stop procedure. I can transform all this into a stop procedure. and make the question. How do I make the question? Once I transformed all these in a store procedure, my procedure will be get answer with my question, specify the deployment model, and get the reply in JSON format, but the procedure itself is also listing the reply below to me. Inside the procedure, I'm including many steps. I'm including the step to get the question, generate the embedding for the question, locate the products related to this question, build the prompt, and make the final call to the GPT model. I'm including all these steps in a single procedure. And the result is brought to me with the main reply, the product's IDs involved in the reply, and the reasoning of this reply. Because I included in the prompt an order for the GPT model to explain how it reached this reply. Okay, let's see this working. Let's see how this works. Let me open the Fabric database again. Demonstration 2. And we can see here in the demonstration 2, the same example that we saw before. My question, my procedure, and the procedure is doing everything for me. So let's take a look. There are two external calls happening. One external call to generate the embeddings for the user question, and one external call to make the question to the GPT model. And let's get the answer. To actually read the answer, I need to put in a notepad to be easier to read. And the GPT model is explaining the details, what the user would need to plan a memorable high school graduation party and the products that could be used for that. See, is explaining and pointing the products. Then I have the list of the products below, immediately below, and mind that I'm retrieving 10 products. The model decided to recommend 4. The model decided that not all products that I retrieved in a vector search were really interesting to be recommended. Only 4 of them were really actually interesting to be recommended. And then the reasoning of the model, why the model built this, the model is explaining. Festive atmosphere for a high school graduation party, include themed decorations, unique graduation cap toppers, versatile tableware, and so on. It's explaining the reasoning the model used to choose the products to be recommended. Okay, this is a first example. Let's try our second example. I would like to cook a chicken teriyaki. So let's execute again. And once again, I have 2 external calls happening. And my answers. So let me copy this. So this is the answer. What the user can use to cook a chicken teriyaki. What sauces can be used to cook a chicken teriyaki. And the model reasons in relation to the answer. And mind that the model recommended 3 products. From the 10 products that I retrieved, the model chose 3 and considered these 3 are the best ones for the question. Select products that are specifically teriyaki marinades and sauces, as these are essential for making chicken teriyaki. Okay, so in this way, we are seeing how the vector search works, and we saw how we can use vector search as itself as a complete solution, or how we can make an additional step and make the question to the GPT models. And for reference, I'm leaving these 3 links for you. The first one is the Git repository with the files from this presentation. The second one is a walkthrough that I didn't illustrate. A walkthrough using Wikipedia information that can be imported in Fabric database and also be used as an example. And the third one is a Walmart walkthrough. But these Walmart walkthrough I use it only as an inspiration, because this Walmart walkthrough can't be followed step by step because it was from before this feature existed. It was built before this feature existed. What I illustrated today is a walkthrough using the same Walmart data, but using the vector information inside the database and making the distance search inside the database. Okay, so this needs to be adapted, but you can get the scripts from the GitHub of the presentation.
Thank you so
Thank you.
much, Dennis. That is a lot of information. I have a question here in the chat which fits, which is, in which Microsoft course can I find more resources about this topic? Is there a link you can share?
The trainings about AI, the Microsoft trainings about AI, 102, if I'm not mistaken, and AI, there is one more basic before 102. They have information about generative AI. They have a good part of the information about the generative AI. About Fabric and the part related to Fabric database, you get in preparation content for especially the DP700, especially the DP700, but you can consider also preparation content for the P600 and the P700. But a good amount of the content, the full content, is about features that were first announced in Ignite. So they don't appear yet in trainings. These that I recommended, they prepare you to reach this stage and use these features, but the exactly content don't appear in trainings yet.
All right, thank you so much for that answer, Dennis. I have another question here from Shi Hao, thanking us for a great session, great explanations. And she is asking, how much would it cost extra to build and maintain this additional workload with the existing team for the business? So the cost of embedding could be primary factor in deciding whether or not to pursue it, given potential benefits. I'm thinking here that if you already have the Fabric capacity and licensing, what is the additional cost or upside compared to, for example, creating an SQL DB in Azure, which is the traditional training that you might see in the Microsoft Learning Paths?
Fabric database are still in preview, so we don't have a precise idea about costs in relation to Fabric database. But I believe they'll be quite comparable with the Azure SQL database costs. So there will be no difference in relation to Fabric database and the Azure database costs. But the calculation is completely different because the Fabric database the cost is calculated in capacity consumption. You buy a fabric capacity and you consume this capacity with many features, and one of these features can be the fabric database. This is part of the solution. The other part of the solution is the Azure OpenAI. If you Google Azure OpenAI pricing, you see a list of price for every call which is made to Azure OpenAI. These calls made from the SQL through Azure OpenAI will add to the price of the solution. But there will be no difference in this case of the price of these calls if these calls are made from an Azure SQL or from a Fabric database. And Fabric database in this case has an advantage because Fabric database can make these kind of analytical calls without disrupting the production environment. While Azure SQL database, there is a good chance that you are talking about a single database, which is also your production environment. You may be dividing the workload between production and this kind of code that may be analytical code. In Fabric, on the Fabric database, they are already isolated workloads.
All right, thank you for that answer. And I see a lot of thank yous here in the chat. So I'm also going to say thank you so much, Dennis, for sharing all of this. It's been a pleasure.
Thank you so much. It was a pleasure to be invited to deliver this session. And as I said, it will be a pleasure to stay in touch. If you would like, you can get my contacts, connect in social media. It will be a pleasure to stay in touch. Thank you very much.
Thank you, Dennis, and have a wonderful evening. And also
Have,
the best to all of you.
thank you. Have a great evening. To
Thank
all of
you.
you, to you too, Emily.
Thank you. All right.
Bye.